using variables, objects, and members. In this nugget, we're going to spend some time talking about the ways that PowerShell stores data and talking about objects, which are really the basis of what PowerShell is and how it works. We'll start off by talking about what variables are, and then we'll look at how to create, populate, and display variables. We'll then look at objects, what objects are, what the term object means, and why you as an administrator should really care about objects. We'll move on to some simple objects like strings of text and numbers, and then look at how to view object members. Members are one of the most important bits about objects because it tells you about the object's capabilities, what you can do with the object. Then we'll look at storing objects and variables and using them, and removing variables from the system. We'll finish up with a nice example on storing credentials in a variable. Credential, believe it or not, is a type of object, and we'll look at that too. And we'll look at how to persist the credential in a variable so that you can use it over and over and over again. Variables can be a kind of abstract concept. I think one of the best ways to think of them is as a sort of container with a name. For example, let's say I've got a container named var. I can assign or put the value 5 into it. At this point, var contains the value 5. Now, just like in algebra, this is a variable, which kind of inherently means the value can change. Let's say I decide I don't want 5 in there anymore. Instead, I want 6. Well, now var contains 6. Nothing about var changes except the fact that it now contains a different value. In Windows PowerShell, I could even say, well, I don't want it to contain a number anymore. I want it to contain a word, like word. Well, now var contains word. You can even kind of use a variable to change that same variable. Let's say, for example, that I start with the value 5 again in var. So that's what it contains. Now I'm going to change it. I'm going to say var equals 5 plus whatever is already in var. So whatever's in var, which is the value 5, will be substituted for var in this equation. So 5 plus 5 is 10, so that's the value that var now contains. This might seem like a kind of a long stretch, but once you see it in operation in the shell, I think it'll probably make a lot more sense, and you'll really see the use for it. So let's open the shell. Now the official way to create a new variable in Windows PowerShell is by running a command called new variable. New variable, name var, and we'll give it the value 5. Great, that's wonderful. The trick is kind of nobody really uses that way. Instead, you can create a new variable and assign it a value just by referring to it for the first time at the command line. Now you'll notice that when I used this command new variable, there's no extra punctuation or anything around the variable name. When you're using a variable pretty much anywhere else, especially at the command line, variable names are always preceded by a $sign. So we'll say var2 equals 10. Now to see what's inside of a variable, I'll just type it at the command line. So it's pretty straightforward to create and populate and even display variables right from the command line. Some of the naming conventions you need to keep in mind are that variable names, when you're using them at the command line again, begin with a $sign. That's just kind of a special character, and it tells PowerShell that, hey, what's coming next is a variable name. From there, the variable name can contain most typable characters. Kind of for sanity's sake, you want to restrict yourself to letters, numbers, and underscores. And typically you want to give your variables a meaningful name, something like age, or year, or counter equals 10. And remember before I said that we're going to jump ahead of ourselves. I'm going to show you one of the math operators. Counter equals whatever's in counter plus 10, which means counter should now equal 20. Nice thing about PowerShell is that you can really play with these variables right at the command line. You don't have to write a fancy script or anything else. You can just type stuff and get it done right here from the command line. Of course, it's possible to put more than just numbers into a variable. We'll take name equals nuggets 2. and that might be a server name, so we can then view that. Notice when I'm putting a string of characters into a variable, the string needs to be contained within quotation marks. And that can either be single quotation marks or double quotation marks. And simply putting a new value into a variable assigns that value into the variable. The equal sign, in fact, is called the assignment operator in Windows PowerShell. And that's what assigns this value to that variable. There's kind of a little trick with Windows PowerShell. Check this out. I've got a name in the variable name right now, but there's nothing stopping me from putting a number in there. So now if I look, it's a 5. Nothing stopped me from going back and putting another name in there. So now I've got a string of characters in there again. Windows PowerShell does recognize the difference between different data types, and we're going to explore this more throughout this nugget. But right now I want to start with these sort of simple types. So let's take a quick break from variables to talk about something in Windows PowerShell called objects. And let's even take a quick step away from computers and talk about a real-world object, something you might see on the street, like maybe a bicycle. Not a very good drawing of a bicycle, but hopefully you get the idea. Got little spokes in the wheels, and this really does become important, trust me. So when you think about an object in the real world, you kind of think of it in terms of its parts and its actions, the things you can do with it. So in a bicycle, we've got parts like a wheel. We have a saddle. There's a pedal. Actually, there's probably more than one pedal. Hopefully, there's probably more than one wheel. Just the one saddle. And some of the actions you can take are to maybe turn left, pedal forward, brake. So these kind of describe what the object is and what the object can do. Well, the same things kind of exist in the computer world when it comes to objects. Only instead of bicycles, obviously, we're going to be dealing with objects on a computer. Some of the objects that live in Windows are things like, well, you've already seen things like files, folders, processes, services, event log entries, all of those things, the things you can see and touch and do things with in Windows, those are all objects too. Only instead of the word parts to describe what they are, we use the word properties. And instead of the word actions to describe what they can do, we use the word methods. Some of the properties of, let's say, a service are its name, its startup mode, whether it's automatic, manual, or disabled, its display name, and its status, which tells us if it's already running, if it's pausing, if it's starting, if it's stopped, whatever else. Some of the methods of a service are stop, start. For some services, it might be pause and resume. You might also think of some of the things you can do to a service that aren't quite as immediate. Maybe change or set the service. And those would also be methods because they're allowing you to do something, to reconfigure some of the service's properties. So Windows PowerShell uses objects to represent almost every type of data that you're going to work with in the shell. The idea is that rather than having to create a bunch of intrinsic functions or a bunch of commands to do all these things, the objects themselves have all the functionality they need. The objects themselves expose all the properties to describe what the object is. The objects themselves expose all these methods which let you do things with the object. Let's take a look at a real-world example, sticking with some simple data types just so that we can kind of get our feet wet. So we'll go back into the shell. And do you want to see a simple object? Let's create a variable named object, assign it hello, and that is a simple object. That string of 5 characters is an object. In fact, objects have different types, right? A file is one type of object, and you would expect a file to have different properties from, say, a service, which is a different type of object. A file has a name, which a service also has, but a file has a length and a last accessed date and a read-only date. Things like that. Services obviously have different properties. Their start mode, so things that a file wouldn't have. So PowerShell does recognize the difference between different types. For example, a string object has a length, and that property tells us that this particular string object is 5 characters long. If I have a number object, though, a number object does not have a length, and if I try to access the length property of a number, I get nothing, because it's not there. Now we talked about methods too. Let's take object and try its toUpper method. Well, that creates a new version of it in all uppercase. If I look inside object, I see that the original version did not change. The toUpper method actually created a new string object that was all uppercase. Taking that same example, let's go back to number and try toUpper. And this time we actually get an error because the type of object called int32 or 32-bit integer doesn't contain a method called toUpper. So that's kind of one of the differences between object types in Windows PowerShell. And it can create a little bit of confusion. Watch this. If I take var and I put hello into it, and maybe instead of putting hello into it, I was reading that out of a file, or I was allowing a user to input that information. Running var toUpper works. Later on, if var somehow gets reassigned a number, now var toUpper won't work. Oops, I have to type toUpper properly, of course. Still doesn't work. So Windows PowerShell is designed to allow you to change the type of object that's inside of a variable on the fly, normally, by default. You can modify that though. I'm now going to, in square brackets, say string, and then type var. This is going to tell PowerShell that I always want var to be a string. No matter what type of data I might try and put in there, I want PowerShell to try and convert it to a string. So we'll start by giving it an easy string, hello, and just verify that I can still run toUpper. I can. Now, without specifying anything again, I'm going to put the number 5 in there. Notice that the 5 does not have quotation marks around it, and when I did this earlier, it changed the type of object in var from a string to a number. And I could tell that because when I tried to run toUpper, int32 doesn't contain a method named toUpper. But now I've told PowerShell that I always want var to be a string. So let's see what it does when I try to run toUpper. Great, it returns an uppercase version. Now, the uppercase version of 5 isn't any different from the lowercase version because it's a number. But the point is that var remained a string, and so it actually has a toUpper number. So a little bit later in this nugget, we're going to look at some of the other data types that you can force PowerShell to use. And we're also going to look at how Windows PowerShell can help you discover all these different properties and methods that an object has. Before we do that, though, I want to kind of sum up the 3 basic data types that I want you to remember at this point. The first is a string, s equals hello. The second is a number, I equals 5. And the third is a date. And the easiest way to get the current date from Windows PowerShell is to run the getDate commandlet. So if I look in S, it says hello. If I look in I, it says 5. And if I look in D, it says a date. So those are the 3 basic data types that we're going to work with in Windows PowerShell. To force it to treat any of these data types would be string S equals hello, int I equals 5, and date time D equals getDate. Now the interesting thing about the date time is that it's capable of recognizing many different string-based date formats. So now that I've forced D to be a date time, if I assign D the string value of December 31st, 1980, and now I look at D, it actually spells that out. Wednesday, December 1st, 1980 at 12 a.m. 12 a.m. being the default because I didn't specify a time. And it did that because it took this string, it knew that D had to be a date time, a real date time, not just a string that looks like a date time. So it took this string, and based on my regional settings, which on this computer are set to month, date, and year, it converted that string value into a real date. When I then displayed the date, it displayed it in the normal, full default format for a date. So those are some of the simple objects that Windows PowerShell supports, and we'll be working with those a bit more as we go on. Now, we've looked earlier at a number of different ways that PowerShell helps you discover capabilities. Things like get command to display all the commands, or help, which displays not only commands but also help. Well, these objects and being able to find their properties and members are also something that Windows PowerShell can help with. So let's start with that date-time value and find out what properties and methods a date-time has that I can work with. To do that, I'm simply going to pipe my object, or a variable containing the object, to a command called getMember. You're going to use getMember a lot. In fact, you should be using getMember so much that it frustrates you to have to type all those letters, and you start looking for a good alias like GM. Here are all the things I can do with a date and time. I can add a certain number of days to it. I can add years and various other time spans to it. I can convert it to binary, to a file time, to a long date string, or to a short date string. I have properties that will extract just portions of the date, such as the date, the day, the millisecond, the second, the year, and so forth. So let's try some of these. Let's start with the properties. What's the day? The day was the 31st. Great. What was the year? The year was 1980. Let's try some of the methods. Why don't you show me D as a short date string? And something that's interesting about methods in Windows PowerShell is that they always have to have parentheses after them. So that is my date as a short date string. That's the same type of string I had put in there originally. Let's try it as a long date string. Oh, see what happens when you don't put the parentheses after? PowerShell just tells you, oh, okay, toLongDateString is a method, and here are some ways that you can use it. So let's try that again with the parentheses. Now, because I asked for a long date string, I'm only getting the date portion of my date time. It's not trying to show me that 12 a.m. portion. Let's try some of the math methods here. We've got add months. Okay, so D equals whatever was already in D, and we'll add 2 months. Now what's D? Now D is Saturday, February 28th, 1981, exactly 2 months later. And it's smart enough to take into account things like leap years, so that if you're using these methods to work with dates and times, you're always going to be working with the right thing. Let's take another type of object. Let's take our string object, which contains hello, and find out what it can do. Remember, just pipe the object to GM. Oh, we can do a lot of things with string. Here's that toUpper method that I showed you earlier. There's a toLower. I can split it. I can replace characters within the string. I can remove characters, pad it to the left or right to make a specific length of string out of it, insert characters, find the index of a particular character within the string, compare it, copy it. There's even the one property, length, and I showed you that one earlier. Here's toLower. Let's try replace. Let's replace all instances of L with O. And the new string has all the L's replaced with O's. So this is how Windows PowerShell helps you discover what an object can do. So let's move on to a more advanced object. Let's find out what I can do with a process object in Windows PowerShell. Well, I know I need to pipe something to GM to see what it can do, but I need to run a command that's going to actually get some processes so that I can pipe them to GM to see what they can do. And the command to do that is getProcess, which has the alias PS. Here's all the things I can do with the process. Lots of methods: cancel, output, read, close, some alias properties, which are a shortcut or a nickname to a property name that's different, and that's where handles, name, PM, and so forth come from. Here's a method called kill, one called refresh. There's a property on here called main module, and all the different properties that describe the process are listed here. But what about some of the other objects we've worked with? How about services? Let's say I want to get a bunch of services and pipe them to GM. Here's all the things I can do with a service. Pause it, refresh it, and some of the properties. Whether or not it can shut down, the machine name, the display name. What about event logs? Get event log system. Let's just get the newest one so this doesn't take very long because we only need to look at one object in order to see its members, its methods and properties. I can convert it to a string. I can see the data, the entry type, its index number, the message, and a few methods here. Probably not many that I'm going to use a lot, but there is one to convert it to a string, maybe to store it in a text file or something like that. So all these different objects in Windows PowerShell have properties and methods, which are collectively referred to as its members. Being able to use the getMember command is the perfect way to find out what members, what properties and methods an object has without having to go look up the documentation somewhere on the internet. So it's a good way to get started working with objects, and it's a good way to remind yourself what an object can do, even if you've been working with that object for quite some time. We've already looked at WMI, so let's take those as an example. Get WMI object, Win32 operating system, and instead of letting it display, we're going to pipe it to getMember. This has got a lot of different properties we can look at, and just a couple of methods. Reboot, set date time. Those probably look familiar from an earlier nugget when we looked up the documentation on Win32 operating system. So we've got lots of capabilities built into these objects. getMember is the thing that will help you discover those capabilities. Sometimes when you're working with objects, it's useful to be able to store them in a variable so that you can work with that snapshot of objects rather than having to retrieve them every single time. That's especially useful when you're retrieving them from a remote machine using WMI, for example. So let's take a variable, procs, and fill it with the results of getProcess. At this point, procs is a static snapshot. If the number of processes on my computer changes, that's not going to update this variable. For example, you'll notice that Notepad is not running. So let's go ahead and run Notepad. If I run getProcess again, you'll see that Notepad shows up on the list. However, if I look inside procs, Notepad isn't on this list because this is just a static snapshot. So I've taken all these objects and I've stored them in the variable procs. There's a couple things I can do with them at this point. If I want to work with just the first one, then in square brackets I'm going to give it the index number 0. That's the first process. The second one would be 1, the third one would be 2, and so forth. If you want to start at the end, -1 is the last object, -2 is the second to the last object, and so forth. Once you've gotten a particular object, you can do something with it. So let me launch Calc, so I can have a process that's not going to hurt my computer here. I'm going to refill the procs variable with getProcess. Let's look at procs and see if calc is in there. There it is. It's actually the first object, which is really useful. So procs 0 is calc. So let's pipe that to getMember, just to remind ourselves of what some of its capabilities are, including this method called kill. Let's try that. Procs 0, so we're just working with the first one, dot kill. Remember to put the parentheses after the method name. And the process went away. You saw calculator disappear from my taskbar down there. So being able to store objects inside of variables makes it a little bit easier to work with them on a one-on-one basis. It also makes it a little bit easier to persist a set of objects over a period of time so that you can work with them. Remember that for something like processes, they're always going to be changing on my computer. So by grabbing them once and sticking them in a variable, I've got a static set that I can work with for that period of time. I can always go back and refresh that by getting the processes that are currently running and putting those into the same variable. When you're finished working with a variable, you might be tempted to remove it. You don't really need to. Once you close Windows PowerShell, all the variables go away automatically. But in case you do want to remove a variable, let's take a look at the variable drive to find one we think we can safely remove. Here's one of the ones we created called object. Now a lot of these other variables are built into PowerShell. You don't want to remove them because you'll change the way the shell operates. fact, a lot of them are marked as read-only variables, so they're protected, but a lot of them can be changed as well. So just be careful. Don't modify those unless you know what you're doing. But this object one is one we created. So let's see. The verb for removing things is remove. So let's see if remove variable name object works. Well, it didn't give me an error message. Let's look at dir variable again. Oh, and it's gone. So let's look at another variable that we might have on here that we could change. Do you see any of the other ones we created, like I or D? This time, let's actually go to the variable drive. This is just a drive, so how do I delete things on a drive? Del I, del D, and del S. Now if I get a directory, I, D, and S variables are all gone. So those are the ways you can remove a variable if for some reason you need to specifically remove it before you actually close the shell. So let's put all of this together now with sort of a practical example. I've showed you before the get credential command. Just run get credential. You can, if you want, put a username on here, but if you don't, you'll be prompted for the username and the password. Now that immediately returns the credential object. And because I ran that at the command line, it wasn't terribly useful. I can't do anything with that credential object because I don't have it stored anywhere. If only there was a way to store an object someplace. Oh, like a variable. $cred equals get credential. Administrator. I'll type in the password. Now this $cred variable contains that credential. So if I've got a command like get wmyObject and I want to run it to retrieve the Win32 operating system class from a remote server called Nuggets5, and that's going to require alternate credentials, I can simply give it the credentials that are stored in that variable. Now I actually do this a lot. I do it so much that it might actually make sense for me to go into my Documents folder, open up my profile, and put this right into my profile. I'll save this, and then open the shell again. Now every time the shell opens, I get prompted for my administrator password. So I'll type it, and now here right at the shell I have access to that cred variable which was created inside my profile. This is just sort of a shortcut for me. It reminds me that, hey, you're probably going to need this credential later because you always use it. In fact, you use it so much, you stuck it in your profile. Now I've got it available to me all the time. I get prompted once when my shell opens, and I can reuse that credential over and over and over. Anytime I need it, I just use $cred. If you get tired of that, or maybe your needs change, it's easy enough just to go back into your profile and take that line right out. Remember to save it, and if you're using the all-signed policy, which you should be using in a production environment, be sure to digitally re-sign your profile so that the signature is intact. In this nugget, we looked at variables, objects, and members. We looked at what variables are and why they exist inside PowerShell. We talked about how to create variables, how to put things inside of a variable, and how to display the contents of a variable. We talked about objects. We talked about properties and methods specifically, which are two types of object members that allow you to work with objects. And we looked at some simple objects as examples, including strings, numbers, and dates. We looked at how to view the members of an object so that you can determine what an object has that you can work with. It's another one of PowerShell's discoverability features. We talked about how to store objects in variables and how to use them when they're stored in a variable. And we finished by talking about how to remove variables from the system. We also looked at an example of working with objects and variables in creating a credential, storing it in a variable for later reuse. I hope this has been informative for you, and I'd like to thank you for viewing.